This video discusses a method of factorizing a quadratic expression. By a quadratic expression qx, we mean an expression of the type ax squared plus bx plus c, where a, b, c are constants or constant real numbers, so that a is different from 0. Now, the restriction that a is different from 0 is important, for otherwise the right hand side of the expression qx is going to be a linear polynomial rather than a quadratic polynomial. Now, an example of q of x would be 3x squared plus 5x minus 2. This is a quadratic expression in which a is 3, b is 5, c is minus 2. Now, factorizing qx means being able to write qx so that it is a product of two linear factors, one kx plus l, the other mx plus n. Now, if we factorize, if we multiply out this expression here, there is the result, which is identical to the original expression ax squared plus bx plus c, as they both are polynomials of degree, degree 2. They are both equal to q of x. Now, this immediately means that the coefficient of x squared in both expressions, this expression and that expression, are equal. The coefficients of x are equal and the constant terms are equal. And this leads to this line here, i.e. that a is equal to km, b is equal to kn plus ml, c is equal to n times l. Now, if we multiply a and c, we get this result here, which says a times c is equal to kn times ml, and that b, we just copy what b is from here, b is equal to kn plus ml. The upshot of this line here is that q of x is factorizable. You can factorize q of x if I can find two numbers whose sum is equal to b and whose product is equal to ac. Okay, I will now show you how to factorize the following quadratic expression. Now, if I look at the first expression, which is 2x squared plus 11x plus 15, and now in this expression, capital A is 2, B is 11, and C is, as you can see, 15. Now, A times C is equal to 2 times 15, which is equal to 30, and B, which is 11, is equal to 5 plus 6, and also therefore AC is equal to 5 times 6. Therefore I can write 2x squared plus 11x plus 15. I can write this as 2x squared plus 5x plus 6x plus 15. Now we look at the first two terms and factor out x to end up with 2x plus 5, and then plus for the other two terms I can factor out 3, and inside I'll be left with 2x plus 5, and hence I'll have 2x plus 5 as a common factor, and inside I'll have x plus 3, and that ends factorizing the first expression. I'll move on to factorize the second expression, which is 8x squared minus 14x plus 5. And once again, a is 8, b is minus 14, c is 5. Now a times c is equal to 8 times 5, which is 40, and b is equal to minus 4 plus minus 10, that is minus 14. And you can see immediately that AC is also equal to minus 4 times minus 10, because AC is equal to 40. And as before, I can write the expression 8x squared minus 14x plus 5. I can write this as 8x squared minus 4x minus 10x plus 5. And if I look at the first two terms and factor out 4x, and inside the bracket I'll have 2x minus 1, and then move on to the last two terms and factor out 5. I'll have minus 2x plus 1, and you will be able to notice immediately this is the same as 2x minus 1 minus 5 2x minus 1, and once again 2x minus 1 is a common factor, and inside is 4x minus 5, and this is the end of factorizing the expression 8x squared minus 14x plus 5.